Hi there, this is Pranav from the PS Diary. I hope you are doing great. Good morning, afternoon, evening, depending on your geographic location. So, in this video, we will talk about sysmon report. So, this is something which has come from one of my very good friend who wanted me to cover this. Okay, and apparently this will be very helpful to many of you. Okay, so we'll cover some sample sysmon report, and then I have around 8 report which I have no plan to share today. We'll go through them. So I have put report 1, report 2, then again sysmon 1, sysmon 2. So basically there are some changes which was done, but what changes were done and how they were done, that we will cover in the upcoming session. So as of now, what we'll do is how the sysmon report looks like, when should that be run, what should be the duration of that, all that thing we are going to cover, and how like where to start this with, how to make sense of it, and when that should be used, right? So let us start. So first thing first, sysmon report is a very lightweight process, okay, so that you can run at any point of time, and the like preferred duration is 10 minutes, but that's not hard and fast. You can even run for 3 minutes or 5 minutes, but don't run for few seconds. That will not really give you no glimpse of the thing that you actually want to see. And no, this is if you don't have access to any server, right? So if there is any client who wants you to do some basic health check, so in that case you can ask them to run sysmon report when their systems are no heavily used by application or something is running, or maybe when they are actually facing the issue of performance. So that time you can ask them to run the sysmon report. Suggest them to run for like 10 minutes, and one report will not give you a lot of ideas, okay, because you need to compare these reports over the period of time to really understand if no something needs to be changed, and if it is, so is that falling in the pattern or no. So having sysmon report on only one day or only 2 days or 3 days will not be very much helpful. You should have it running for a couple of days, and then you should suggest them only when you find a pattern. If there is no pattern, then maybe it's no one of the issues. So we should not focus too much on that. So this gives you overall idea of the server, does not necessarily give everything, okay, but then this is one of the no powerful tool. So first thing first, so this will give you the version of Sybase that you are running currently on that server. So it is 16, you can see SP03PL11. When this was run, so you can see April 9, 2024, when the sampling started and when the sampling ended. So you can see this was run for 10 minutes. Now there is two option in that. So one is to clear and one is to not clear. So we prefer not to do clear. So it should be no clear. Okay. So this will also tell you when was the counter last cleared. So if we have run this prior to this sysmon report with no clear, or that's the default one, so that will give you overall idea like when the server was rebooted. Okay, so that is first thing. Now we have this utilization, so this will basically give you how many cores are there on the server. So you can see 0, 1, 2, which means it has got 3 cores. What's the utilization? CPU utilization, you see 42.6%. So this percent is basically average of utilization over this 10 minute. So within this time 10:45 to 10:55, the average utilization was 42.6%. It's possible that you can have spike in between, and even it could be utilized little lesser, but this will give you average of the utilization 42.6%. So the other thing is IO busy. So in case of any system which is no heavily used for reporting, in that case you will see IO busy will be higher. Okay, that is no, because lot of asynchronous activity will be happening, so disk activity will happen, that's why this percent will be higher. Okay, so 42.6% is a like good usage. It's not too less, it's not too high. Now let us go through this report. So first is utilization that we saw. Then let's scroll down slowly. Not everything we will go through, or I mean for any DBA we don't no recommend to read each and every line, but we should see what is the issue that no client is facing or we want to solve, and no based on that we should no focus, not like everything has to be checked. Okay, so total CPU yield, so you see here 44.1, so this is your OS utilization. Okay, so that was kernel, this is OS. So far so good here. Now context switches at OS, so we will not get into that. Now come down slowly, and mind you this is 16 AC 16 version. Okay, we will also see the report of 12.5. Parallel query management, task management. Okay, now this is something which we generally look at it. So task context switches due to, so all this percent will actually add up to 100%. Okay, so what we have to see whether any of the counters are really very high, and if that needs to be looked at it. So this will give you just an idea, not the complete detail. So basically for detail you should get into that category, and then you should see how is it. Okay, so as the name of this file is spin log contention, so that means in this report there must be spin log which must have been higher, and then we will tell you how do we address it, and like first of all how do we find it, right? How do we find it, then how do we address it will come later. So here you see voluntary yield 10%, that's perfectly fine. CPU usage and your memory usage. So cache miss is 0.8%, so it's very good. Okay, so cache miss means it is not able to get all data that it needs from the memory, it has to go to disk to read the data. Okay, so you see here network packet received 57.5%, so network related stuff is there. So what is the network packet size which is there on the server has to be checked, but then again as I said before, it has to be checked over the pattern, and then only we can take a call. So overall this looks pretty good here, I don't see any problem as such. Okay, it is saying tuning your network IO subsystem because this network packet received is very high, but nothing to be concerned as of now from that point. Okay, now application management, we don't need to look at it. Scroll down. Now this transaction profile, this is very important for me. Okay, this gives detail about what all transactions are happening and what are the types of it. Okay, so this will basically be divided into multiple parts. Okay, but then what we have to see is what is the percent of APL heap table, which means all page locking heap table. I know frequently ask in the interview like what's the difference in the heap and table, and many people are not very clear on that. So heap is also a table, but then it doesn't have clustered index defined. Okay, so as you can see in this environment, 61.3% of the tables are heap having all page locking. That doesn't mean that 61% table of overall tables are heap. So this is basically the snapshot of 10-minute only, right? So within that 10-minute, whatever tables were used, out of that 61.3% were having APL heap table. Then APL cluster table. So this is, as you can see, this was heap, doesn't have cluster index, and this is cluster table. APL means all page locking. Now then we have data only lock table. So this could be either data row or data page, either of them. So here you see 61.3% is APL. So that means this environment can have lock contention and can also be vulnerable to deadlocks. Okay, so deadlock is something that we'll cover in a different session, but here this is about, so this gives you some sort of idea. Okay, now total rows inserted, so per second how many rows are inserted, so you can see how busy is your server and whether it's write intensive or Right also it gives you whether insert intensive or update intensive or delete intensive, all that it will give you here, and in each category you will see that APL and then data only locked. Okay. Now direct and deferred, I have talked about that in my previous session, so you can find that out, what's the difference in deferred update and direct update. Okay, so this one looks good. So first of all, I mean first section you were having update, okay, insert, update, and then you have delete. So now, I mean this should give you some sort of understanding that this environment is no update intensive or delete intensive or insert intensive. So if it is delete intensive, then you have to take care of the tables according to that. If it is insert, it will have different logic. So this will give you some sort of no basic understanding on what needs to be done. Okay, transaction management, we talked about it in high level view. Now index management, insert, update requiring maintenance and all that. Index scans, ascending index, ascending scan, data only lock, ascending scans, all that. I mean these things are informational, nothing like no glaring as such, so we can just go through that. Okay, lock management, so this is important, but again it depends on the problem that you are trying to solve. If there is no concern which has been raised for locking, then you can ignore it, but overall it will give you some idea, like exclusive table no granted, then waited, so everything is granted here, there is no problem in the locking. Okay, shared, how many were requested, how many granted, how many were waited, so all that you see there is 0 in waiting, so it's all fine. Okay, let's move to the next part. Deadlock detection, so you see deadlock searches, and then average deadlock per search, so it is 0, there is no deadlock at that point of time. So whatever we are talking about, it is in that no glimpse, that like 10 minutes of snapshot, right? Now this is very important, data cache management. This is no this is where sysmon comes very handy and helps us in finding out how is the cache doing and what can be done, right? So spin lock, as the name suggests, so we'll find something here in for the spin lock. Let us see. So here you see 99.6% is the cache hit, which means it has been able to find that much data in the cache. Only 0.4% of the data which was not there in the cache, it had to go for the no disk to read the data. Okay, large IO. Now let's go next and see. Okay, so with spin lock held, it is good, there is no problem here. Now this will actually list all the cache that you have in the system, so it could be default data cache will be by default, then whatever named cache you have in the system like dvcc underscore cache, then if you have any other named cache that you have declared, that will come here. Okay, it will also give you recommendation based on the usage, but then you should not fall for this, you have to find the pattern and then only you should take a call. So default data cache, now you see the spin lock contention is 12.7%, which is not something at the acceptable range. So anything above 10% is something that needs to be looked at and then should be addressed. Okay, so this is what is a no glaring point or something alarming in this particular report, and this should be addressed. So cache, as we talked about, there is no problem in that. So now how will you address the spin lock contention? So first of all you have to see where it's happening. So it's happening in default data cache. So you have to find out the detail of default data cache. Okay, so I have taken one session about default data cache and all about cache, so you can go through that. And then we have also talked about partitioning, so which is a static parameter. So doing more partitioning to default data caches could help in addressing spin lock. Now there is another thing. So if you see the page, this thing like what is the pool size here, so it starts with 2K, then 4K and 16K. Even this I have covered in the cache session, but anything which is starting with 2K, that means the page size is 2K here, okay, and maximum you can go is 8 times, which is 16. So in this environment the page size is 2K, even though it's not mentioned, but it is explicitly telling you that. Okay, so I think we are good for this one. Yeah. Now spin log contention report 2 I have. So basically in this one the previous issue was addressed. Now April 24th, right? So this one was taken on April 9. So within 2 weeks we got the approval from client, and we have been able to address it. So you see number of cores have not changed. Now maybe we can go to spin log directly. Okay, so that was in the default data cache, right? Default data cache, and now you see the value has changed to 3%, which is very much in the acceptable range. Now this default data cache miss is not that much reduced because we have not done anything to address that, right? So if you have not done anything to address that, value will remain more or less same. So cache miss 0.4%, and here also you see cache miss is 0.4%. Okay, this is taken again for 10 minutes, 1907, 1917, and this one is 10. So it's taken a different timestamp, but ideally what we should do is we should compare apple to apple, meaning the sysmon snapshot should be taken approximately at the same time to understand whether the impact, whatever change we have done has positive impact or no. Okay. Now this is large server, so basically it has got higher number of CPU, okay, higher number of cores. So let us go through this report. This is again 16 version, as you can see here. So this one has got your 12 cores allocated to Sybase, and usage is 23.1, and you see here the IO busy percent is 48.5, which is almost double of your user busy percent. That means it is very active for reporting purpose or for anything where heavy volume of data is being written or inserted or updated, okay, or deleted. So now let's go further on that. Let us see what we can make. So this one, I don't think there's any problem in this, but just to get some idea. Yeah, so there is one thing that you should see, page fault. This is something which comes in the sysmon report. So if you see anything which is listing in the major fault, okay, so you should really see, you can find detail about that in the error log, and then a lot of things are there which needs to be checked either at the SAP site, or if there is any detail no given, or if there is any compatibility issue between these two, or the version of Sybase itself, right, that has to be checked. So you see here it's only 1.6 per transaction per second, it's high. So this is something which needs to be checked. So in this report, I think that is one which had to be checked. Now let us see the task context switches in this particular report. Okay, so here 16.8% is totally fine. Cache miss is 7.1%. So not too high, but yeah, maybe we can check further on that. Last log page write 11.5 and network packet 36.0. So since it's already heavy in terms of reporting or any like disk operation, so that means it is sending and receiving a lot of network packets or data of or data over the network. Okay. Now here let's go and see the transaction profile. How does it look like? So here you see APL heap table is only 0.1%, clustered is 0.2, and data only lock table is 99.7%. So this environment is already very heavy for read write operation, and a lot of data is being transferred over the network. So since log data only log table 99.7%, not overall table numbers, but when the snapshot was being taken, that means the locking contention will be very less compared to the previous sysmon report that we saw, right? So this is no kind of very good server or very good environment, at least for lock contention. So the chance of deadlock or blocking will be less, much less than what we saw in the previous report. Again, you will have insert, you can see here, then update and delete, all that will be there. So even this percentage you can make out 14.9%, 9.6 and 31.3 like that. Okay. So transaction management is fine, we will not get into details of that. Index management is fine. Log management, so granted, weighted. So you see there are some places where there is weighting, but then it's too less. Okay, exclusive page. So now let's get into the data cache management. So here you see 0.3% is the cache miss. So again, this is very good. There is no issue with the cache configuration. We seem to be doing good here. Let us see if there is anything else. So previous one was having 2K page size, right? Now here let us see what is the pool size. So large IO is 16, default data cache. So this is also 2K page size, you can see 2K. Okay, and then the spin log contention, it is 2.7%. So we are totally fine here, nothing alarming as such. So only thing that seems to be the issue here is the major fault. Not major, actually it's minor fault, right? That's the only thing. So let's get into the large server sysmon report 2 here. Let me see if we did anything to reduce that. 1100 per second and 1200 per second. So maybe we did something to do fix for this one. Okay. So now how do we address that? So that is not entirely issue with Sybase, right? So that is something, it's either compatibility issue or some setting at the OS level that has to be checked. Okay. So now let's see this huge cache miss. So this is 12.5, as you can see, 12.5 version. This is again run for 10 minutes. Okay. So you see here CPU busy. Now this is 4 core server. So we have allocated 4 cores to Sybase. So usage 49.3% and IO busy is 21.7%. So this is again high for, high usage for CPU. IO is also used, it's not 0. Now we have told about the high cache, right? So let us go and see the task context switches. What is the value? So you see here it's a 94%. This is one of our client where like lot of things are legacy, even their disk and operating system is very old, that we still support them. So you see the cache search misses 94%. So that is what we have to check. Now this we have to see this cache miss is happening from which cache. Is it default data cache or there is some other named cache and all that, right? So 12.5 looks little bit differently from 16 report, but overall things remain same. Okay, how you make sense of transaction profile will still be there, right? So APL heap table, you see here 98.2% is the heap, which is not very good in for the locking. Lock contention can very much be there, but only based on that log contention you cannot suggest anything to client unless you observe blocking or deadlock through error log or blocking through if that gets reported, or if you have any monitoring tool which can suggest, which can find out when the locking was actually happening or blocking was happening. Okay. Now let us see what we have. So this is your data cache management. So here cache hit is 97.3 and miss is 2.7. So in the previous reports we saw it was less than 1%, right? 0 point something was there. Here it's much higher. Let us see which one we can actually find out where is the issue. 95.5. Now default data cache miss is 2.7%. It's not too less, but it's not too high also. So this is also having 2K page size. Based on pool configuration you can tell. Okay. Did I miss anywhere any cache? Default data cache. Spin lock is also high, if you can see 8.0%. One minute. So this is fine. 2.7, 2.7. So this itself is resulting into that much of cache miss. So here you see the cache miss is 90 something, right? 94%. So that 2.7% cache miss is resulting into this much cache miss. Now this is something not very trustworthy. You need to see couple of reports to take a call on this. Okay, otherwise it's hard for us to really suggest anything. Okay, so let's see the second one now. 12.5 huge cache miss. So let us see if we can find something here. So total cache miss is 0.3. So this is also fine. Now we can actually check what is the cache search miss which will come in the first one. So here you see 70.6%. So which means cache could be either under configured or the pool configurations are not really balanced, or it's not how it is supposed to be. Okay, so that has to be checked. Now cache miss 4 core report 1. Now in this one, so it is 4 core server. Again this is 16.0 SP03 PL05 and the sampling interval is 10 minutes. Let us see the task context switches. So here it is 18.4%, right? So now anything else is there which is alarming? So no, it is 71.8, which is other cause, which is not none. So now if you do the cache miss, let us see. So here it's 5.5%. So it's much higher than the previous report. Now let us see if there is any specific cache where we have the miss. Yeah, see here, this is very clear, right? So from this tempdb underscore cache, this miss is happening. Now which one you will allocate like memory to, which pool you will suggest to extend, that again depends on the usage of the pool, large IO and other thing. And also we need to see what is the size of tempdb, what is the binding of tempdb underscore cache. Is it having only tempdb binding, or there are some other tempdb which is having binding with this particular database or with this particular cache. Okay, so that was one of that. Now I think this one we have solved it. So let us see what is the value now after solution. Tempdb cache, right? 25.0% and it was 24. So I think it's not solved. Yeah, maybe it has not been addressed when it was captured. So May 15, 2025, and this one is same day. Okay, so this has not been addressed 1848, and so it's actually before that. Okay, so how this will be addressed, again we have to see the detail of that particular cache, the size of temp db, and then all the binding which is done for that temp db underscore cache. So as you can see, this value is very high, 5.5, and this needs to be addressed. So temp db underscore cache is the only one which is which needs solution or which needs to be addressed. Other cache which is here, like your default data cache and syslogs underscore cache, so those things are working perfectly fine. Now here again you can make out the what is the no max page size, it is 4K because the 4K and 32K. Okay, so we covered sysmon report, how do we read that, how to make sense of it, and then what all things we can suggest based on certain findings, right? So logging is something that we saw, major minor fault is something that we saw, and we also saw like no cache miss, how that is there, and also spin log, right? So we have covered all that, and in the next one maybe we can show you how did we solve it, what was the value of configuration, what had to be changed from which value to what value, and then how did that address the issue. Okay, yeah, so do let me know in case of any question on the sysmon part. Yeah, thank you very much.